All right, welcome to day 14 of the SAT Countdown series, and today we're going to discuss inequalities. Now, yesterday in day 15, if you haven't checked out that video, go check it out. We talked about linear equations. I talked what a slope is, how to find the slope, a slope-intercept form, how to solve some problems regarding a slope or given points or finding the equation of the line, and at the end we touched a little bit into simultaneous linear equations as well, but we will come back to the simultaneous linear equations because I haven't discussed how you can solve them not with Desmos, which we will probably come back to it in a few days. But for today, I have a linear inequalities rather, for you, and I have decided to break this topic down into a few subparts. So we're going to do a little introduction of inequalities and what they are, how they might be useful. Then we're going to look into solving simple one-variable inequalities, followed by compound inequalities, where we have inequalities on both sides of the equation. Then we're going to look into graphing linear inequalities in two variables. We might use some help of Desmos here. Then we're going to look into word problems with inequalities. This is a big one because SAT exam is usually involved questions, word problems when it comes to inequalities. Sometimes we have to come up with the equation. Sometimes we just need to come up with the equation and then solve the equation to find the answer we need. And then we're going to look into absolute value inequalities. And lastly, we're going to look into system of inequalities. In some of these subparts, we're going to use the help of Desmos. That's why I have it open here. And I also want you guys to get used to it because Desmos is a big part of the SAT exam, and the more comfortable we get with it, the easier our life will be. Sometimes we can save a lot of time using Desmos. All right, so let's get started with the first one, which is going to be Introduction to Inequalities. So what are inequalities? Inequalities, or at least linear inequalities, is basically, well, in terms of the presentation, they look very similar to linear equations that we have dealt with. But here we don't necessarily look for a specific value, but rather range of values. For example, in linear equations, we use the equal sign to represent if x is equal to a value, let's say 5. But in inequalities, that sign will change. We're going to use 4 different signs. I know most of you are familiar with this, but just to quickly go through them. So we've got less, we've got more, we've got less and equal, we've got more and equal. All right, so this is less, more, less equal, less or equal, less or equal, and more or equal. More or equal. Right? Again, we can write it the same way we use in equations. X less than 5, x more than 5, x greater or less equal than 5, and x greater or equal than 5. So example to the first one could be, let me change the color here. The example for the first one could be, for example, 4. 4 is less than 5, so that's a true statement. 6 is greater than 5, that's a true statement for the second one. X less than 5 equal or less, so 5 would work, or anything to the left of 5, meaning negative infinity to 5. And the last one is going to be, again, 5 will work for this one as well, but 5 to positive infinity. Now, the only thing here is whenever we're solving linear inequalities, the basic version of it, for example, let's say, let me do a little example here for you guys, 3x minus 7 greater than 8. Now all we have to do is just treat it the same way we treated equations, but the only thing we have to be mindful of is multiplying with a negative value. Now I don't think we need to do it here, but let's try to solve it first. So again, I keep my variables in one side and numbers on the other side. So to get rid of negative 7 on the left, I need to add negative well, I need to add 7 to both sides. That's going to give me 3x greater than 15, and x is going to be greater than 5. So in a line, I like to represent it this way because to me it makes more sense. So 5 is, let me put it here actually. So 5 is our starting point. In fact, I'm going to draw like that. So this is 5, and our answer is 5 and above. Now, why did I put a circle here? Because 5 is not included. How do I know it's not included? Because it's not greater equal. It's not that, it's just equal. Just greater. So 5 is not included, but anything above 5 is the solution of this equation. You can always check your answers to find out if you did it right or no by plugging in numbers in either on the correct side of the equation or on the wrong. For example, if you want to disprove it, you can put 0. If you put 0, you will get -7 greater than 8, which is a false statement. So that kind of supports your idea. Another example is about that multiplication thing I talked about. So -2x plus 5 less equal 11. Again, I'm going to do the same thing, move numbers to one side. -2x less equal than 6. Now, I need to find x, not negative x. So I need to divide this by -2. If I divide this by -2, this is going to be x, and this is going to be -3. But all I need to be paying attention here is to change the sign. Whenever we're dividing or multiplying by negative value, the sign always have to change. Sign always have to change to the opposite. And now we have x is greater than -3. So if this is -3, I'm going to put a full circle here. No, not a gap like this one here on the left. Not like this one, because 3 is part of it, and 3 to positive infinity would be the solution to this. When it comes to compound inequalities, the idea is the same as solving just regular one variable inequalities. All we have to do is try to make x in the middle, well, try to make the middle x at the end of the day. So whatever process we do, somehow we need to get to this shape. Okay, and whatever helps us to do that, we're going to do that step by step. So I see there's 2x plus 1. So 1 is extra here. I need to get rid of 1, which means subtracting 1 from all 3, not just 1. In all 3, I'll subtract 1. This is going to be -5, less than 2x, less than 8 minus 1, 7. Okay, I'm getting close, as you can see. Now the 2 is extra there. I need to get rid of 2, which means dividing it by 2. And that's going to be -2.5 less x less equal 3.5. So our answer is values between -2.5 and 3.5 included. Right? You have to pay attention to these values because one is included, one is not. If you show it with brackets, this one will be a regular bracket, -2.5, because it's not included, and the other one will be a square bracket because 3.5 is included. All right, let's do another example. 3x minus 5. 3x minus 5 greater than 7, it says, or x plus 2 less equal than -1. So we have two inequalities here, right? And we have this or in between. Now, whenever we're dealing with compound inequalities, we have cases where we can use and or. And means both conditions must be true, and or means either condition is true. So and is an overlap, or is a union. Okay, so we're going to solve this one because there's or in between. We're going to look for the union. Okay, so let's take a look. 3x greater than 12 x is going to be greater than 4. That's good. That's my first solution. X is less than -3. Now, here's what union will mean. X is, this is -3. So one solution is this. And the other solution is 4 and above. This is not included. 4 and above. So obviously, our solution will be union, which is -infinity to -3 and 4 to +infinity. Okay, so -infinity to 3. 3 is included, right? And union 4 to +infinity. Now, if we had and instead of or, that would change things up quite a bit because we don't really have an overlap. So this one would have no solution. And when it comes to graphing linear inequalities, we don't usually get questions like graphing actual graph based on the inequality, but rather we get questions where we have to either be able to understand the graph or read the graph or imagine how the graph would look like based on the conditions that we have. Now, same way we have obviously, because it's a linear inequalities, the graph is similar to linear equations in terms of they're both straight lines, right? So if I have y equal to 2x plus 3, we know that that's a straight line. If I say y less than 2x plus 3, that's also going to be a straight line. Okay, so let's try it out. 2x plus 3, that's a straight line with a positive slope. Y less than 2x plus 3. Now, this one is, well, I said that it's a straight line. The beginning of it is a straight line, but it covers a region, right? Like we said at the beginning, inequalities about a range. They're not about specific value. Okay, so as you can see, it says y less than 2x plus 3. So less means below that graph. That's why we get this blue part. Okay, if I put y greater than 2x plus 3, then I'll get above that graph. Okay, so let's see what else can we do here. Now, if I zoom into this, hopefully you guys can see that. Did I zoom in too much? There you go. Now I can zoom in. I don't know if you are able to tell. Actually, you can tell it from here that this is a dashed line. Now, why is it a dashed line? That's because it's not less equal, so these points are not included, right? If I change it to less equal, I get a straight line. Now, it's very hard to notice on the graph here because of the pixels, I guess, but it does make a difference. It does make a difference. So if I change it to, again, this, actually maybe that you can notice, look, I'll do Control Z, and this one, you can see that dashed line changing from straight solid to a dashed line. So whenever we're dealing with graph of linear inequalities, we have case 1 where we have a solid line, and we have a case 2 which is a dashed line. Again, when do we get a dashed line? When we use boundary not included. We get a solid line when the boundaries are included. Now, when it comes to testing a point to see if it is part of the solution or not, we can always do a plug, take a point from the graph and just see whether it's above the graph or below the graph. So for example, we have y minus 2x plus 3 here. Okay, I can take this point of, for example, -2 and 2. Let me see if I can find that. It's here. Yes. You see that this is not part of the area that is shaded, so this will be not our solution, right? We'll see that in examples soon. All right, let's try to solve this question here. Does the point 31 satisfies y greater than 2x minus 5? Now, what we can do, we can plug and play, okay? So option 1, let me make it a bit bigger here. So option 1 is we take 3 and 1, so 3 for x, 1 for y. So I put 1 here, greater than 2 times 3 minus 5, which is equal to 1. Now, is 1 greater or equal to 1? Yes, it is. So this should satisfy it. Or what I can do, let me clear these points. I can say y is greater than 2x minus 5. That should give me the region, right? You see, actually now you can see the dashed line. Yes, it's more obvious now because of the color. And let's pick that point, 3 and 1. 3 and 1. Where is 3 and 1? Yes, 3 and 1 is right here. It's on the line. On the line, so it does satisfy the equation. Now, word problems are probably the most interesting part of inequalities when it comes to SAT exam. Now, what do we have to pay attention when it comes to word problems is the wording, obviously, because it's a word problem. Now, what type of words are we looking for here? So usually in the question you would get cases like at most, or at least, or you will get less than, or more than. Now, it's very important to identify these key points when you're solving these questions, and because, you know, misunderstanding of wording can basically ruin your whole solution. So let's take a look at an example here. I've got two questions here. Let's take a look at them. A gym charges $50 to sign up and $20 plus $20 a month. If the budget is less than 130, how many months can we sign up for? The question wording is a bit strange, but a gym charges $50 to sign up and $20 per month. So we have an initial cost of $50, right? And $20 for every month that you go. We can actually create a linear model here. So if you think of it as a graph, that's not a straight line. So this is price, this is a month, right? So it starts at 50, that's your initial cost. And for every month that you go to, month 1, month 2, you add extra. So this will be 70, 90, etc. And the budget is less than 130. So our linear model is like that. 50 plus 20m, m meaning the month, right, should be less than or equal to 130. Yes, that is that's our equation, right? We can just solve that now very simply, just moving numbers to one side. So 20m is going to be less equal 80, and m is going to be less than 4. So we can afford 4 months. That's our max, basically. This is what we can, that's how much we can go to gym with that amount of budget. Now, the second one says a student needs more than 120 volunteer hours. They already did 87. How many more hours do they need? Now, this is very, very simple one, right? This is a very simple one. They need more than 120. They already did 87. So 87, yes, 87. Let me try this. So 87 plus whatever hours we're looking for should be greater than 120, greater or equal 120. So we can do the math there and move it around. So x is going to be greater than 33. So we need more than 33 hours. Okay, but there's more interesting word problems, and we're going to solve them soon. So first one says Valentina bought 2 containers of beads. The first container, 30% of the beads are red. In the second container, 70% of the beads are red. Together the container have at least, remember the keywords, at least 400 red balls, which inequality shows this relationship where X is the total number of beads in the first container and Y is the total number of beads in the second container. So X is the first container, yes, and Y is the second container. The 30% of the beads are red. So 0.3x of the first container is red, excuse me, and 70% of the second container is red. Now together there is at least 400 beads. So which means what? At least means 400 or more. So X or X beads in X, red beads in X plus in Y should be greater than, at least 400 means greater equal than 400. Now we can just substitute the stuff we just did. 0.3x plus 0.7y is going to be greater 400. Yes, which is it A? Yes, it is A. Okay, let's look at the next one. On a car trip, Red and Jessica each drove for part of the trip, and the total distance they drove was under 220 miles. Red, I don't know if you how to spell your name or pronounce the name. Red drove at average speed of 35, so under 220 miles. Under means what? We should start thinking about these as we go through them. So under means less than, right? Red drove an average speed of 30 miles per hour, 35 miles per hour, and Jessica drove average speed of 40 miles per hour. Which of the following inequalities represents this solution where R is the number of hours Red drove and J is the number of hours Jessica drove? Now, this comes down to a very famous equation, so from physics. Doesn't mean you have to know physics, but distance is equal to speed times what? Time, right? Or velocity times time, doesn't matter. Now, the velocities are given. One of them is 35 and the other one is 40. Okay, we need to multiply them with some sort of time and add them, so it ends up being 220, right? So what is the time that Red drove? That's R. What's the time Jessica drove? That's J. So 35R plus 40J should be less than 220. So the answer is going to be, we have to be careful when we pick the answer because they're all very similar. It's not 40R, not this one, A or B, and less than 220. So our answer is going to be B. All right, last thing I want to do in terms of inequalities is talk about how we can treat absolute value questions. These usually confuses people, but with a bit of knowledge, I think we can make easy work of it, right? So let's walk through them through example. Okay, now I've got, let's write example here. I've got x, absolute value of x minus 4 less than 6. Now, if I treat it as a regular linear inequality, I would say x minus 4 less than 6. X should be less than what? Less than 10. Now, while this is part of the solution, but we are missing out. Now, what are we missing out? We're missing out part of the solution. Why? Because absolute values can be positive and negative, right? So meaning, if this is my part 1, the part 2 is the case when x minus 4 gets out of absolute value as a negative value, meaning negative x minus 4 is less than 6, negative x plus 4 less than 6, negative x less than 2, and x greater than negative 2. Right? Why did sign change? Because I multiplied by negative value. Remember at the beginning I said you have to be very careful when you're dividing and multiplying by negative value when it comes to inequalities, because that can make or break your answer. So what do we have here? We have two values, negative 2 and 10. So first answer is less than 10, so this part. And the second answer is greater than negative 2. Okay? Since we need both of them, we need values that satisfy both of them. We're going to take the overlap. So the overlap is going to be this region, which is between negative 2 and 10, when none of them are included. Okay? Now, how else can you solve it? You can solve it using the compound inequalities that we learned. Some people might do it a lot easier. So what do? We say, let me go down here. Because we can open x minus 4 positive and negative, we're going to write that in the middle. We're going to make it less than 6. This is for the positive case. And for the negative case, we're going to make it bigger than negative 6. Now we just try to leave x in the middle. So I add 4 to all three sides. I'm going to have negative 2, x, and 10. Now as you can see, this is much quicker than the first version I did, but I like the first version because it really helps you to understand what is actually happening. But once you understand that, then you can do it quickly. Let's do one more example on this one before we move on. And let me see. So we've got 2x plus 3 greater than 7. Again, pause the video if you need to and try to solve it on your own. I'm going to do it with the second version. So negative 7 less equal, I don't need the absolute value anymore, 2x plus 3 less equal 7. So subtract negative 3 in all sides. 2x, 4, divide by 2, negative 5 less than x less equal 2. There you go. So our answer is between negative 5 and 2, and both of them are included. This is going to be the last section of this video, system of inequalities. Now, when we talked about system of linear equations, we said their intersection point is the solution to the system of equation. Now, if they don't have any intersection point, that means the system of equation does not have a solution. So, same goes for inequalities, sort of, but here we're not looking for points again, like I mentioned earlier. We're looking for a region, right? So the solution to a system of inequalities would be a region that's overlapping. So a region from equation 1, the region from equation 2, whatever the overlapping region is, that is going to be our solution. Now, usually SAT questions would be like, find out if this point is the solution to this system of equation, which means you have to see if your value is in the overlapping part. Okay, let's try it out. So I've got an equations here. What do I have? I have a system of equation y greater than x plus 1 and y less equal negative 2 x plus 5, and the question says find out whether 0, 0 or 0, negative 4, 0, 0 and 0, 4, not negative 4, 0, 4 is on the region. Now what we can do, we can solve this simultaneous equation manually and find out the point of intersection, and then kind of go from there to see if the points will be on the graph or not. But that's a long and inefficient way, and because we're in the exam, we're short in time, we can just plug it into the graph, right? And then find the region y less equal negative 2x plus 5. There you go. So the shaded region is this dark part. And then we can just see. We can see, or we can check. So I'll plug it in 0 and 0, just to be sure. And then 0 and 4. There you go. Now we can see that 0, 0 is definitely not in the region, because the region is this dark part. And so is 0, 4 actually. 0, 4. Oh no, this red one is the other one. There you go. Oh yes, 0, 4 is actually. So 0, 4 is here. And it is part of the region. So this is not, and this one is. Again, when you're solving system of inequalities, all you have to do usually is just put them into the decimals, see what the overlapping part is, and then check to see if your points are part of that region or not.